Liquid junction potential. Liquid junction potential is a potential developed at any interface or junction where there is a separation between the charge. So we can define liquid junction potential as potential developed at any interface or junction where there is a separation between the charge. So, for example, if we consider a half cell of Daniell cell and consider a zinc rod dipped in zinc sulfate solution. So the interface of the zinc rod and the zinc sulfate solution, potential development is there at the interface of the zinc rod and the zinc sulfate solution. It is also considered as liquid junction potential. So if you are constructing a concentration cell, electrolyte concentration cell, consider this is an electrolyte concentration cell. So, this is the boundary between these two electrolytes. So, here liquid junction potential is the potential developed around this boundary. So, for electrolyte concentration cell, just consider we are going to make an electrolyte concentration cell with transference and without transference. And the EMF of this cell, electromotive force of these cells with the transference is going to take as EWT, and if the EMF without transfer is WOT, then the liquid junction potential EJ can be calculated as E with the transference minus E without transference. So we can calculate the liquid junction potential of the cell. And this value is normally equal to 2T plus minus 1 into RT by F ln A plus or minus 1 divided by A plus or minus 2. So here this is the transference number, R is gas constant, T is temperature, F Faraday's constant, A plus or minus 1 and A plus or minus 2 are activities. So from this equation it is clear that liquid junction potential depends the transference number of the cations and anions, and it depends the activity of the electrolytes. Okay. And the relation between with transference and without transference of the same cell equal to E with transference divided by E without transference is always equal to 2T. So this will also help to calculate the liquid junction potential of electrolyte concentration cells. And by using the transport number of cations and anions, we can rewrite this equation like this. We know T plus T minus equal to 1. Right. So the equation EJ equal to 2T minus 1 RT by F ln A plus or minus 2 divided by A plus or minus 1 can be written like this. Thus here we can write it as 2T minus T plus minus T minus, and the remaining portion RT by F ln A plus or minus 2 divided by A plus or minus 1. And here this is equal to T minus T plus divide into RT by F ln A plus or minus 2 divided by A plus or minus 1. This is the liquid junction potential. Okay. Next one is polarization. Polarization is the phenomena of changing electrolyte potential from equilibrium value. Okay, it's the process of changing electrode potential from equilibrium value. So normally the value we are calculating as the EMF of the cell is a theoretical value, right? Practically the electrode potential will be greater than this theoretical value. And the phenomenon is known as polarization, and the excess potential is known as polarization current. So that is cell require more voltage than the theoretical value, and the excess voltage is known as polarization current. Okay, so many reasons are there for polarization. The first one is deposition of metals may causes polarization. Then concentration change of the electrolyte may causes polarization. So if there is any change in the concentration of the electrolyte, that will directly depends the potential of the cell. And the change in equilibrium potential value from the theoretical value, where the concentration is known as concentration polarization. And this concentration polarization leads to the slow movement of ion through the electrolyte, and that is the reason behind polarization. And we can reduce concentration polarization by continuous stirring, or we can increase the temperature and reduce concentration polarization. And then other reasons are the product of electrolysis may convert inert electrode to active form. Inert electrode to active electrode. For example, if we are conducting electrolysis acidic or alkalic solution, just imagine that we are going to construct a half cell by using a platinum electrode and an acid. During electrolysis, what happens is H2 and O2 gases are evolved from this cell, and there is a possibility to develop a back EMF. That is, this evolvement of hydrogen and oxygen gas created hydrogen electrode and oxygen electrode respectively in this half cell, and that may leads to the production of a back EMF. In the case of this particular type of platinum acid solution, about 1.7 volt will be developed as a back EMF, and that may also leads to polarization. And the accumulated gases, the next reason is this accumulated gas arise resistance to normal cell flow. So arise resistance to normal cell flow. So the formation of these type of gases, that is hydrogen or gases, may reduce the flow of cations and anions within this electrolyte media, and hence we have to give extra voltage to occur the cell reaction. So that is also a reason behind polarization. Okay. So from the above, it is clear that one of the reason behind polarization is back EMF. So if we want to conduct continuous electrolysis in a cell, we have to provide extra EMF, or we have to provide extra voltage to occur the cell reaction. And that extra voltage is required to overcome this back EMF. And the extra voltage we are given to overcome back EMF is known as decomposition potential. So we can define decomposition potential as the minimum voltage required to overcome back EMF and to produce continuous electrolysis. Okay, and this decomposition potential can be calculated from the voltage current curve. So by plotting a curve in which voltage is on x-axis and the current is on y-axis, current corresponding to the voltage given, we'll get a graph like this, and at a point the current will increases suddenly and we'll get a steep curve. From the steep increase or from the sudden, so from the steep curve or from the sudden increase, we can determine the decomposition potential. So by plotting two line like this, we'll get an intersecting point here, and this intersecting point determines the decomposition potential. So this is decomposition potential. Okay, the next term we are going to familiarize is over voltage. This is actually a surface phenomenon. Okay, so actually this is the difference between the potential of the electrode when gas evolution occurs and between the standard electrode potential of the cell. So over voltage is the difference between the potential of the electrode when gas evolution take place. So we can take this electrode potential as E, and standard potential of the cell. So we can take it as E0. And this is over voltage. So over voltage can be equal to E minus E0. So this is actually related with the evolution of gases. So the most common evolved gases are hydrogen, oxygen, etc. Other evolution of other gases also causes over voltage, but the most commonly studied evolution of hydrogen and oxygen. So the difference in potential when evolution of hydrogen gas take place and the standard electrode is known as hydrogen over voltage. If the evolution is of oxygen, then the difference between the potential of the electrode when oxygen evolution take place and the standard potential is oxygen over voltage. Okay, let's explain this in detail. Consider we are going to conduct electrolysis of water. And here is a positive electrode and a negative electrode. During electrolysis, what happens is H plus ions and O2 minus ions will be formed in this medium, in this electrolyte. This H plus ions will move towards negative electrode, and the O2 minus ions will move toward positive electrode. That is, cations will move towards cathode and anions will move towards anode. Right. So the cell reaction, entire cell reaction can be represented like this. Water will be dissociated like H2 plus half O2. That is hydrogen gas. Here during electrolysis, gas bubbles will be formed at positive electrode, around positive electrode and negative electrode. And the gas bubbles formed in negative electrode is hydrogen gas, and the gas bubbles formed in the positive electrode is O2. Right, O2 gas bubbles. So hydrogen gas and oxygen gas will be evolved during the electrolysis process. So if we measure the electrode potential of the cell, it will be little bit higher than the reversible potential of oxygen and hydrogen electrode. So the cell here, the cell EMF is little bit higher than the individual reversible potential of oxygen and the hydrogen. And the extra potential is known as over potential. Since this overvoltage occurs due to the production of gas bubbles, it is also known as bubble overvoltage. Bubble overvoltage. And we already told that this is a surface phenomena. This is a surface phenomena. So, and this overvoltage depends the rate at which the gas bubbles discharge at electrodes and how these gas bubbles are discharged at the electrodes.